Hi, my name is Jonathan Tan Jacob, and today I'll be sharing on my EMATH 3 assignment. And I'll be and firstly I'll be explaining what Euler method is, how to solve an initial value problem using an Excel spreadsheet, and how to calculate the approximation error using Euler's method. So what is Euler's method? Euler's method is a numerical technique used to approximate the solution of a first order ordinary differential equation. A differential equation in the form of dy over dx equal f x y. Often, we don't know what the original curve looks like. We only know the slope or rate of change, as in the derivative. So we approximate the shape of the curve by taking small steps. So how does this work? We start at the known point of x0, y0 over here, and we draw a tangent line using the slope at that point. Then we move a small step forward in x, which will give you x1 and y1 by using what is known as step size, which is h. To estimate the next value of y using the formula yn plus 1 equals yn plus h times f prime xn yn. This formula is derived from the rise over run slope and gives us an approximation for the next point. We repeat the same process to get further values. As the step size decreases, the approximation becomes more accurate. I've used Microsoft Excel to implement Euler's method with a step size of 0.01. To find xn, we use this formula where b7 is the previous x value and this is the fixed step size. For y, c7 is the previous y value and b7 is the current x value. Well, this is the step size. I filled down the formulas until n equals 100, where x equals 1, and the estimated value is 1.914443. Using this Excel, we can even calculate the actual value using this formula, where x equals 1, y bracket 1 equals 1.91485,422. But calculating it on paper, given that dy over dx equals x squared plus 1 over y, where y is bigger than 0, y bracket 0 equals 1, find the approximate value of y bracket 1. So using this formula, you get y equals plus minus 1.91485. We reject the negative because we are given y bracket 0 equals 1. This tells us the solution must go through a positive value at x equals 0. Now, to calculate the approximate error, we take the actual value minus the approximate value, which would give us 1.91485 minus 1.914443, which will give us an approximate error of 0.000407. That is all. Thank you so much for watching.